Hi, I'd like to give you a quick demo of a PowerShell script I've written that will allow you to change space priorities of processes, albeit automatically, so we can decide who gets what share of the CPU, so you can punish overabusers or uh, actually ignore them if you want. Say it's an important Excel macro for a specific user, then we can actually not punish that. The choice is yours. I'll talk about the options very briefly later. So what have we got? Okay, so we've got Task Manager down at the bottom here showing the process IDs. And then we've got two PowerShell windows, one where I'm going to run my script, so I'm going to kick that off now. Run it in verbose mode so we can see what's going on. So I'm running it with an increased frequency of 15 seconds, the default is 60, but obviously that can be changed by parameter. So it takes a snapshot of the processes every 15 seconds and sees how much CPU as a percentage it's used in that 15-second period. So if something's used 100% CPU, it means it's used 15 seconds CPU. It might actually use more if it's multi-threaded. So at the moment, my box is fairly well behaved. Notice nothing's changed other than the PowerShell running the script itself. PID12612 has been changed to high, which gives it a better chance of being able to change priorities on a very busy system. So what I'm going to do over here in this other PowerShell window, PID11688, is generate a synthetic CPU load, not messing around with factorials or anything like that, just good old tight loop. So now we'll see down at the bottom that PID11688 has got a high CPU. Within 15 seconds that'll be picked up by the script. It'll tell us how much CPU it's used as a percentage of that 15 seconds and change its base priority accordingly. So 106%, so it's at more than 15 seconds. Well, it must have more than one thread active. So we can see now at the bottom it's been set to below normal. What does that mean? Well, any other process coming along at a higher priority, such as normal, as we can see most processes are, will have preferential access to the CPU. If I now stop that script running, so the CPU returns to 0, it'll spot that, and within 15 seconds, depending on how much of that 15-second slice it was busy for, it will either pick it up on this run or the next one. So it's picked it up, so it's only used 23% of the CPU in that 15-second period. So we can see at the bottom now, PID11688 has had its priority changed back to normal. And that's pretty much all there is to it. So I'll now exit script. We notice, just to tidy up, that our process 12612 has had its priority changed back to normal. So if I do anything silly in there, again, it's not going to potentially hold the CPU. And we can exclude processes based on name, users, include based on name, user. Also, just do it for my own session. By default, it excludes session 0, so system processes and services. So you can see 148 of those are excluded. You can mess with those if you want, but sometimes that can cause problems. My experience with these sorts of products in the past. But run it as a logon in a logon script or scheduled task logon, so a user can run it for themselves, but you might not want to run it for other power users, or you could wrap it in a service, one of the many service wrappers out there, to run it across all sessions on a box. Run it as an administrator and it will have access to all sessions, excluding 0 unless you actually explicitly tell it to include 0. That's all there is to it. Released to GitHub shortly. Hope that makes sense. Cheers.